Hello everyone, good day. Welcome again to Java tutorial. So for today, I'm going to discuss to you the uh, the difference between primitive data types and reference data types. So let's go back again to our workspace. So let's create here a class. So let's say the basic let's say data types. Okay, so let's click on finish. All right. So let's make this one, let's zoom this one out so that it will be viewable. All right. So in most programming languages, of course, data typing is very important. So data types are actually used for declaring a variable, which we also know that variables are actually used to hold information or data. So whether you get to ask the information about from the user, getting their names, their age, their address, their gender, their contact number or their salary, their course, and things like those, or things like those are actually the an entry to your program. So, and this eventually stores those entry, and this usually stores those entry to your program, and it will actually allocate a certain, mm, it will actually allocate a certain address. All right. So for in other language, especially in Python, you don't have to explicitly type a or define a variable using any type, okay, because it's dynamic typing. But in Java, you have to explicitly define or explicitly define a certain type. But let's talk about these data types. So first is when we say data types in Java, there are actually two types of it. There's this what we call primitive data types, and there is this what we call reference data types. And in some other books, it's actually um, called as wrapper classes or special classes. Okay, so let's start with the very basic type or primitive types in Java. So again, we have primitive types. So primitive types actually actual value, stores actual value. So once you get to define a variable under a specific type using primitive type, it actually stores an actual value. You say, let's say for an instance, you store num. Num actually stores actual number, which is 5. Okay, that's a primitive type. So if you are going to, let's say, create another, let's say, let's say double, let's say, price. Let's go to something like that, and then you have float um, point grade equals, let's say, 1.5. Okay, but in Java you have to specifically put an F after the initialization of the in float to specify if it is a float value or a double value. But uh, let's try to visit each of these types. What's the role of these types in programming? Okay, so right here, we have actually certain types of data types. So to start with, we have number one, int. Okay, so another one is we have, let's say we have car or char for characters, and then we have byte, we have short, we have long, we have float, double, sorry, and then we have boolean. So int is actually numerical value. So the first, yeah, so numerical value, yeah, these are actually numerical value. So you have here an int. Okay, so when we talk about int, this is actually, it can actually stores, it can actually store up to like 2 billion or like 4 bytes. So let's start with the this one right here. So from smaller ones to, yeah, smaller ones to bigger ones. Okay, let's start with byte. So byte means it's it's actually one bit. So one bit is actually 128 bytes. So the price the number or range values for byte is actually uh, positive 127 to negative 128 or negative 128. So that's from the minimum value of negative to positive 127. Okay, so meaning to say, if you are going to define a variable, let's say byte or byte value, and then you say um, uh, 120, so it's still valid because it has not uh, exceeded the range value. So if ever you will be initializing, or you initialize the value more than 127 and below 128, say for an instance 128, so it will give you actually an error, and it will tell you type mismatch cannot convert from int to byte. So we can actually typecast this, but for now, let's focus on the data types. So anything that exceeds or is more than if you are going to initialize the byte to more than 127, let's say 130, it is going to always gives you an error. As well as if you are going to, let's say, declare less than 129. So that would mean the byte can only store values specifically from negative 128 to 127. So data types in Java are actually like a a container or a glass or a container. Yeah, it's a container. So there are containers that are smaller or smaller ones. There are containers that are medium size, large size, and so these containers basically can store as much as data as it can based or depending on their sizes. So just like byte, so if we are going to relate byte as into a glass, so meaning it can only store up to 128 I mean can store up to 127 ml of water as a container. So basically that is the limit. So next is let's proceed to short. So if in case you are going to use a short, let's say as your variable or as your data type, short is actually a 2 bytes. So that is 32,000. So the range value is actually 32,768 negative to 32,767. So meaning to say you can store as much as number from in between negative 32,768 until 32,767, or in between these numbers. So beyond that, let's say you are going to store any number, let's say short more equals let's say 29, so it will give you an error. So because again, it can only store up to this based on this limit or range. Okay. Now, for character, you can actually initialize character, let's say ch as like this. Okay, character is what happened? Let's sorry, it should be 0. I mean, for this one, for characters is whatever in Java uses the the characters that you see in the keyboard, including other special characters. It actually uses the Unicode characters. It's actually still 2 bytes. It can actually, I mean, it follows the Unicode characters. I don't know what's the exact ano for character. I mean, limit for character, but it's somewhere or approximate value is up to 82,782,000 or something like that. So basically, character will just it's going to store single character in your program. It's and it's this one is numeric under numerical value in let's say for an instance we have here car uh, ch2 equals ch1 or ch plus something like you can actually do that or you can actually do like c. So but you'll have to typecast this one I guess. So yeah, you'll have to typecast, which we will be discussing typecasting later on. I mean, this is sorry two. What happened? Ch. It's because we don't declare any value for ch. Let's say for an instance, something like that, and then so what happened? I see. Because you have to do that, something like that. We will discuss this typecasting in the next lesson. Okay, another is you have integer. So if you are going to declare a variable or a value under this type or under this data type, it can actually store much more. So in fact, int is actually it's actually 4 bytes, and it can actually I don't remember exactly, but it's like 2 billion. But later on, I'm gonna show you how to know the max value of int and min value of int rather. And for long, it's actually uh, what's the fifth one? Quintillion, 9 quintillion. So it's basically 8 bytes. It's basically 8 bytes. Yeah. And then also we have here float. For float, you have here 4 bytes. Okay, so that's basically the byte space it is going to consume. So this one is 8 bytes. The difference between the two is that this float right here is can actually has actually 6 to 7 precision. So 6 to 7 precision, meaning to say uh, up to 6 to 7 decimal point float can only store. So let's say for an instance, float. Let's try. So ff is equal to right, can it store more than that? So it's basically cannot. So it's 6 to 7 only. 6 to 7. Let's try. 1, 2, 3, 4, 5, 6, 7. That's it. And for actually, let's try more than that. It won't. But if you are going to display the value of float, I guess the value would be up to 30. I mean up to only 5. Yeah. So 1, 2, 3, 4, 5, 6. Yeah, it's 6 to 7. So up to this value only, decimal point or decimal or precisions. For double, let's say, let's copy paste this one. So this one is higher than float with 8 bytes and with actually uh, how much 15 precisions or decimal places. So meaning to say you can actually store, or when you are going to display this one, so it will give you up to 15 decimal precisions. Up to 15 decimal points. Yeah, so you can actually count it. And then for Boolean, we have true or false. It's either true or a false. It's 1 bit. And then I forgot the long. So long is actually 8 bytes, the same with double, only that it doesn't have a decimal point. So this one is a lot bigger compared to int. So these are basically your primitive types. Now, each of this type has actually equivalent reference type in Java or wrapper classes. So, yeah, let's have this one to next. Ano na lang. So you have here reference type or wrapper classes. So this reference types actually it does not store the actual value, but rather it stores the memory address. So it's basically stores memory address that points to the actual value. So what is that? What do you mean by that? Example, if I'm going to declare integer, let's say x1 is equal to 34, it only means that so if since we have int here val 23, so 23 is actually stored. 23 is actually stored to val directly. Okay, directly. Actually, no, actual, directly or actual value. While in reference type or upper classes, the only difference between the two is that uh, this x1, okay, this x1 here actually stores the address. Let's say the memory address of x1 is fxc0012. Let's say that's the memory address. So it is stored to x1. Okay, and this actually point, but I'm not saying this is the address, no, this is the allocation, or this is the allocated address or memory address for x1. It's randomly given. So the Java will the actually the Java has the manipulation of that. I mean, it's going to be the heap that is going to, which is going to manage that one, no? Memory man in terms of memory allocation and memory management. And this actually, which actually points to that points to the actual value. So in this case, the x1 stores the address, which is this one, and this address actually stores the actual value, which is 34. So that's actually the difference between this reference classes and uh, primitive types. But one most important difference between each of this, actually each of these primitive types has equivalent reference types. Okay, so I'm gonna erase this one. Okay, so I have integer, I have float. So So as I've said earlier, that all Java classes starts with capital letters. So basically, reference types are classes. They are actually called as wrapper classes. They are special types now, which actually the only difference between, okay, let's start with the Let's be very straightforward. So let's start with if you have a primitive type, let's say num1, it's let's say 25. The only difference between the two is actually this one. So uh, while this one it stores the actual value, while this one stores the memory address that points to the actual value, which is 34. The another uh, like distinction between the two is that this wrapper classes, which is x1, can actually call methods belong to an integer, which is that is something that you cannot do for primitive types. Example, num1 dot. So once you pair it with that, or you write that and after the variable, you cannot call the like the methods or the operations inside or of this type, because it's primitive type. So basically it's like your cell phone. So this one is your keypad, no, keypad cell phone, and this one is your smartphones, which actually composed of it's a way better in terms of its feature. So the keypad cell phone has only limited features, while smartphones has actually a lot of features, but they are actually the same in terms of their goals. But it's only a matter of features. So again, going back, num1, you cannot do anything like that. So here in x1, I can actually call some of the methods belong to that class. So I can actually reverse, I can actually convert to hexadecimal string, I can actually get the value of to string and sign. I can actually get the max value, mean value, but there is only two limitations, like only two numbers. I can actually get and call the properties max value and mean value. Let's try. So let's say we would like to know, oh, this is what I've told you. I haven't memorized the basta it's like 2 billion, but I actually do not I actually don't memorize the other like numbers or whatsoever. So let's say for an instance, x1 right here. So x1 max value. So x1, just change this to mean value. So int basically and integer are just the same. With in terms of the max value, it's capable of storing, and the mean value, it's actually the same. Only that this x1 as a variable of integer wrapper class can actually call some properties or and methods inside of this integer class. So let's run this program, and then you will see here it's hundreds, thousands, millions, and billions. Yeah, it's 2,147,483,647 max value. So the range value of our integer, and negative 214 billion for 748 million 300 648 648. Tama ba? Oh, yeah, it's positive, negative. So that's the one of the differences in of primitive and reference. Another is, let's say we are going to call, let's say x1 that you can compare to, you can have like max. So let's say 3 and 5. So it will display the, let's say, max, highest. Highest is only that it's limited to only two numbers. So let's highest is 5. Let's say for an instance you declare int num1 num2 is equal to 7. So and then you are going to substitute the value of num1 to num2 right here. So num1 and num2. So it's going to display 25 as the highest value. Hopefully. right? So highest is 25. So you can also do that for like mean, and then you can even convert it some like, wait for a while. You can even convert a value, let's say x1 uh, to to binary, yeah, to binary string. Let's say we are going to convert the 25 or num1. Sige, let's say num1, which is the value of num1 is 25. So let's convert 25. So it's like using the 8 bits, starting with the uh, it's 128, 64, 32, 16, 8, 4, 2, and 1. So it's going to be 0, of course, 0, 0, this is 1. So this is like 0. Ah, 8 plus 16 is 24. So this is 1. This is 0, this is 0, and this is 1. So basically, it's 1, 1, 0, 0, 1. So I hope we are correct. So we have here 1, 1, yeah, 1, 1, 0, 0, 1. So yeah, something like that. And you cannot do that to a primitive type. So again, it's similarly, you can do the same for float, for double, for double D, uh, what else? Boolean, let's say Boolean B is, let's say, true. Uh, what else? Long L, byte B, short S. Okay. And for B's, because we already have B, byte BB. And for character, so in character has primitive type char ch, I mean char, but for reference type you can use actually character. And this characters actually contains a lot of methods uh, that are really uh, useful in manipulating string. Let's say character char. No, because it's a keyword. It's a keyword. ch2. So let's say ch2 that you can actually uh, have here digit is character, space character is number, no, is alphabet. So it's going to give you true or false if it's if the 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 argument that is being passed is either a alphabet or not. We will discuss some of this in the next chapter. So that's for character car. So the only thing difference with like long is still long in primitive type, but in here still long, but with character char, and then in reference type it becomes character. And another one which is actually a string, no string, which is a very it's a special uh, it's also a class which contains a lot of methods for manipulating string. And there's actually more. So we have big int. Yeah, so big int. You can actually have big decimal. So these are some of the primitive types. So I mean reference types. And aside from which doesn't have equivalent primitive types. So big integer, big decimal, so big byte, then it's used for uh, big numbers, used for large amount of numbers. So in programming or competitive programming, we normally use this reference classes. Okay, so I guess that would be all for today. As a recap, we have there are two types of uh, data types. First is the primitive type. So primitive types normally starts with or normally spelled with lower cases, and it stores the actual value, and it does not it cannot call, it doesn't have methods, it cannot call a certain property. I mean, it doesn't have properties or methods and belong to it or containing it, while reference classes are actually wrapper classes, which actually stores the memory address that points to the actual value, just like what we have discussed earlier. And then each of the primitive type has actually reference type or reference data types or wrapper classes equivalent, which actually uh, the distinction between the two is that aside from it stores the reference classes can store memory address, this reference classes can actually take advantage of calling properties like max value, min value, and some methods containing it, which you cannot do that in reference data type. So I guess that's it. I hope I was able to help you in terms of understanding difference the difference between the two. So thank you guys for listening and have a great day. Bye bye.